Artemis III should have been a moon landing. That was the plan. But somewhere along the way, plans changed. In April 2026, 4 astronauts splashed down in the Pacific Ocean, the first humans to return from the moon in over 50 years. America is watching. The world is watching. And China? China is watching. Very carefully. Because Beijing has already announced their target, a crewed lunar landing. Their own astronauts, their own flag, their own moon base. By 2030. NASA has only a few years to prove it can do more than reach the moon, that it can stay. We live on a small blue rock, orbiting an average star, one of 400 billion in this galaxy alone. Our solar system is 9 trillion kilometers across. The nearest star is 40 trillion kilometers away. And yet, here we are. Curious enough to question the sky, stubborn enough to leave. The farthest humans have ever been is just beyond the moon. In cosmic terms, that is nothing. But this time, the mission is going to Earth orbit first. Why? Because Artemis III has to test a complete system, and every single part of it has to work. The Orion spacecraft, the suits, the SLS rocket, 2 different moon landers, and tanker vehicles for a fuel system built entirely in orbit. So before Orion ever leaves the ground, all of that infrastructure has to exist first. Right now, the suits are still being adjusted. The landers are still under development, and no human has ever refueled a spacecraft in deep space, not once. But the moon has been sitting there for 4.5 billion years. It will still be there, even if it takes us another 60 years to stay there. Orion is nearly ready. It's the spacecraft that carries the crew, the capsule at the top of the rocket. But Orion doesn't land on the moon. It doesn't even get there by itself. For that, the landers need to already be waiting in Earth orbit, launched separately by SpaceX and Blue Origin. And everything comes down to 3 moments. Step 1. Orion launches into Earth orbit. Step 2. The rendezvous. Orion finds the moon lander in orbit. Step 3. The docking. Never done before at this scale. A small crew capsule connecting with a vehicle the size of a 12-story building. For a few seconds, both vehicles have to pretend they're standing perfectly still. 2 machines moving faster than a rifle bullet. The capsule adjusts its angle, millimeter by millimeter, and then a mechanical click. Docking confirmed. Let's be honest, doing this for the first time, near the moon, with almost no abort options, that's maybe not a great idea. So instead, Artemis III will most likely be a test mission. Just like Apollo 9 in the 60s. Before humans ever landed on the moon, NASA tested everything in Earth orbit first. Docking, separation, life support. It was boring. It was unglamorous. And it was the reason Neil Armstrong didn't die. For decades, space exploration was about reaching new places. Now, it's about building something that lasts. That is how you create a moon base that stays. To get Orion off the ground, NASA built the most powerful rocket since Apollo, the SLS. 98 meters tall, 6 engines firing together, building 8.8 million pounds of thrust. It does exactly one job: lift everything off this planet. Once. It takes 8 minutes for the SLS to do its job. 8 minutes to cross the boundary between Earth and space. And then, silence. The rocket falls away, burning back through the atmosphere, and Orion drifts forward. Alone. No vibration anymore. No noise. just the quiet hum of life support systems and a window. Earth, very small now. That small blue rock orbiting an average star. The crew doesn't have long to sit with that. There is work to do. Now they're in Earth orbit, but to reach the moon, Orion needs something new. A lander. Actually, two of them. Two of the most powerful spacecraft ever created. And this new generation isn't being led by NASA alone. It's built by private companies. One from SpaceX, the company behind Starship. One from Blue Origin, Jeff Bezos' space company. Both trying to prove they can carry humans to the moon before the other one does. And neither of them has ever done it. Not in space, not with a crew, and definitely not together with Orion. SpaceX is building a massive lunar lander with a side-mounted elevator so astronauts can descend directly to the surface. Musk himself said the long-term goal is a self-sustaining city on the moon. Blue Origin is taking a different approach. Their Pathfinder mission carries no crew, just hardware, proving the vehicle can land safely before any human gets aboard. Two completely different systems, two private companies competing to prove their spacecraft can keep humans alive. And if all of this works, if all these systems actually come together, then one day, someone on the moon will pick up a coffee cup and realize the hardest part of the mission is this droppy, floating coffee. Here's the thing that makes Artemis completely different from every moon mission before it. Those landers need fuel, a lot of it, far more than any single launch can carry to orbit. So this mission needs a system, in orbit, one that has to be fully built before the mission even begins, step by step, launch by launch, until everything is in place, waiting in microgravity, waiting for humans to arrive. Think of it like a pit stop in orbit. The car is a 172-foot rocket, and we're building a service station between the worlds. Artemis isn't a moon mission anymore. It's space infrastructure. Now, imagine stepping onto the moon. The first thing between you and death is your spacesuit. Minus 280 degrees in shadow, plus 130 in sunlight. Micrometeorites, razor-sharp dust. No atmosphere. Inside the helmet, you hear your own breathing, the slight hiss of the oxygen system, your heartbeat. The suit maintains pressure, temperature, air. It keeps the outside world outside. The next generation spacesuit, the Axiom Extravehicular Mobility Unit, was designed specifically for the moon by Axiom Space and fashion house Prada. Seriously, Prada is helping to design the suit astronauts will wear on another world. The result is the most advanced wearable system ever built, and probably the best-looking one, which could accidentally make this the first fashion show on the moon. But this is not clothing. It's a small artificial Earth wrapped around a human body. The further we travel into space, the more Earth we carry with us. Who will trust these systems enough to step aboard? We don't know yet. But whoever they are, they've already been to a place very much like the moon. You can build the perfect rocket, the perfect suit, the perfect lander, and none of it matters if the astronaut standing on the moon doesn't know what they're looking at. Northern Arizona, the San Francisco volcanic field, a landscape of black lava rock and ancient craters, one of the most moon-like places on Earth. That's where NASA sent the Artemis III crew to train. The exercise is called JET, Joint EVA Test Team, the highest fidelity moon landing simulation ever conducted on Earth. Full spacesuits, real-time communication with mission control, Astronauts crouching over basalt rocks with hammers and chisels, collecting samples. Think of the moon's surface as a 4.5 billion year archive. No atmosphere, no weather, no plate tectonics. Every impact, every cosmic event, still there, frozen in the rock, exactly as it happened. You can't read that archive with a robot. You need a human who can look at a crater wall and notice something. Harrison Schmitt did exactly that on Apollo 17. He spotted orange soil, volcanic glass beads 3.6 billion years old. Robots had rolled past the same area for hours without noticing it. NASA chose Arizona because the volcanic terrain is almost identical to parts of the moon. The basalts, the breccias, same material, same origin. Not by accident. The Earth and the Moon share a history. A planetary collision 4.5 billion years ago that nearly destroyed early Earth and threw a chunk of molten rock into orbit. That became our moon. And now, billions of years later, the children of that collision are picking up pieces of it on Earth to learn how to pick up pieces of it on the moon. The universe set that up a very long time ago. Astronauts, geologists, and flight control, they have to speak geology under time pressure, in suits, with a communications delay. Jet 5 tested exactly that. There's a term NASA uses for what happens when the plan has to change because the crew finds something unexpected. Flexecution. On the moon, there's no second chance to go back to an interesting rock. You see it, you collect it, or you leave it forever. That's why some of the world's most highly trained aerospace engineers are out in the Arizona desert, smashing rocks with hammers. In the heat, getting their boots dirty. This is how you walk on the moon. One hammer swing at a time. At the end of a jet training day, someone sets down a hammer, pulls off a glove, looks up at the sky for a moment. Nothing dramatic, just a person standing in volcanic dust, looking up. Somewhere in the near future, a crew will actually do this. Climb into Orion, reach Earth orbit, dock with a spacecraft, step inside, and trust their lives to all of those systems. They know history rarely remembers the test missions first. Still, these are sometimes the ones that matter most. Space history is full of giant moments, but before every giant leap, there were smaller steps, quietly making it possible. Perhaps, far in the future, the real story of Artemis III will sound like this. A civilization born on one small planet brings life into dead worlds. And the question will no longer be whether life exists somewhere else in the universe, but whether it came from Earth. There is more to explore. See you beyond the stars.